Therefore, yes, it does have an inverse now, right? It is 1 to 1. Now we can find its inverse. But we gotta pay attention to the domain. Do we understand? Yes? Okay, so for f to have an inverse, it must be a 1-to-1 function. What does that mean? It must pass what? The vertical line test and the horizontal line test. Okay? And this is important because later on we're going to get to some problems and we're going to be trying to solve for, we're going to try to solve for x. And the only way that we're going to be able to solve for x is by guessing and checking. Thinking of a number, plugging it in, and seeing if we get that answer. Okay? Because we're going to end up with problems that are like cubic, and we don't know the cubic formula, right? There's not a cubic formula like a quadratic formula, right? To solve cubic problems. So for those ones, we're going to have to guess and check. We're going to have to look at the problem, think of a number, plug it in, and see if it works out. But then some kids always tell me, well, sir, how do I know that that's the only answer, right? Because you're thinking, well, it's cubic. It could have more than one x value, right? No, it's not going to happen because we're saying that the functions are what? 1-to-1. That means there's only going to be one x that will ever give me that y. And vice versa. Do you understand? So there's no doubt as to what if there's some other number that could work. That's why it's important to know this, okay? The other thing that I'm going to mention here just for fun is monotonic. What does that mean? Always increasing or always decreasing. So monotonic functions always have an inverse. Okay, so what are some examples of monotonic functions that we've talked about? So exponential, like e to the x, right? Or a to the x, any number to the x power. Okay, what about other monotonic functions? Logs, right? Logarithms are monotonic functions. Okay, any other ones? The cubic function, right? That's a monotonic function. It's always increasing. Okay, you got to be careful, right? Which cubic function it is. Linear, is linear always increasing? Positive x or negative, it could always be decreasing. So there's a lot of different examples. Cool? Alright, so now let's jump into it and let's work with this table here and see what we can do with it. Ready? What are they giving us in the table? X values, Y values for F, and Y values for G. Okay, what does this table want us to give us? X values and Y values for the what? For the inverse of F. Orale. How do I do that? Swap? What do I swap? So like I would swap those two? Oh, okay, because it's with the F. That's the Y and that's the X. So I need to swap them. So this number would be what? 3 and this one would be? Oh, okay, cool. Okay, what would be the other one? 2 and 1. Okay, so these are now my x's and these are my y's for the inverse, right? Okay. How about for the G inverse? What would those be? Now we're looking at this guy and this guy, right? So it would be 1 comma what? Negative 2, and the other one would be? Negative 2 and 1. Oh, okay, cool. Are we good? Is everybody okay doing that? They gave you a table. Could you find the inverses of the functions that they're giving you? Yes? That's a skill that you're going to need. Alright, now let's apply that skill. Now they want to find f of g inverse of negative 2. So what do I start off by finding? The inside part, right? So g inverse of negative 2, okay? So can I find that? Let's say I didn't have this table. How would you do it? Flip them first, so you would like flip them on your own over here, and then do it? Okay, so like, let's say I didn't want to flip them and write them over here. What would I know this is? This is an x for the inverse, right? Because it's being plugged in there, but it's actually a what? A y for the original function, right? So I would be looking for where does this function g have a y of what? -2, and the answer to that one would be the x value, right? You understand? It's kind of a way of working backwards. So here inside, g inverse of -2 is what? Is 1. So now I want f of 1. And I can look at my original table. What's f of 1? 2. And we're done. Easy? Alright, try the next one. What do you think is going to happen here if I have f inverse of f of 1? What do we say inverses of each other do to each other? They cancel out? Okay. So what do you think the answer is going to be there? 1? I don't know, let's try it. So what's f of 1? 2, okay. So now we want f inverse of 2. And what's f inverse of 2? Oh, you were right. Cool. We said that when two functions are inverses, they cancel each other out, and the answer should be what? Should be what?
X.
X, right? Whatever that number or that thing that was in there, right? So here, what was in there? 1. So these guys should cancel each other out, and I should be left with that, and that's what I was left with. Pretty cool? Alright. How about the next one? G inverse of f inverse of 2. Now those two are not inverses of each other, right? So they should not cancel each other out. Okay, but let's see what we get. What's f inverse of 2? 1, right? I can go to my table. And now I want g inverse of 1. I go to this table. -2? Cool? Alright. How about the next one? Do you notice anything there that can save me some time? G of G inverse, right? So I know that these two guys are inverses, they'll cancel each other out, and they should end up giving me what? 1. So now I want f inverse of 1, and what would f inverse of 1 be? 2? So let's see, go to f inverse, go to, oh wait. There's no 1. 3, 2, can we add a 1? Sure. This went like -2 to 1 is how many? 3? You want to go another 3? Do we know if it's linear? How do I know if it's linear?
Did she say attention seniors?
Yeah.
That's
right.
Instead of someone else.
They said something?
Yeah.
Attention seniors.
I got confused.
The whole time.
When?
Right now.
Right now, they just said like attention.
I
I didn't just hear that alone.
Outside.
I heard it.
Are you serious?
They said the beer.
So you're definitely not insane.
I didn't
Okay.
hear anything.
I didn't hear it. So, can I figure out f inverse of 1 with what I'm given? No. Okay, I can't figure out f inverse of 1 with what I'm given, so therefore I'm just going to say that it's what? Undefined. Okay? I need more information in order to use what they gave me to figure something out, right? They only gave me 2 points. Maybe if I had 3 or 4 points, I could see if they had a constant slope, therefore it would be a line, that I could use it, right? But here, I can't determine that. Cool? Alright, so are we okay with that?
Yep.
Alright, so now let's practice a little bit finding the inverse algebraically by hand, like we did in pre-cal. But before we do that, let's write the steps that you told me earlier. So what was the first thing that we had to do? Switch x and y. The moment you do that, you already have the inverse. What was the second thing? Make it y equals. And the third thing was to label as the inverse. actually, before you switch x and y, you should think about the graph and how it looks and see if it has an inverse, right? Before I try to find it. So before I do anything, I should do the horizontal line test, right? To the sketch of that graph in my head before I try to find it. Because if it doesn't pass the test, let's not even waste our time looking for one, right? So looking at this guy, what should this one be? Should be a line, right? So some line, I don't know, whatever. Positive slope. I'm just trying to sketch. So does it pass the vertical and horizontal line test?
Yes.
So is it 1 to 1?
Yes.
Yes, every x will only have one y. There's no cheating going on. Can you tell me its domain and its range? All real numbers and all real numbers. Okay, I can plug in any x that I want, right? And I'll always get any y. Good? Alright, so let's find its inverse. What do I do first? Now that I know it has one. So x equals 6y plus 2. Okay. And make it y equals minus 2. X minus 2 equals 6y. Divide by 6. Y equals x minus 2 over 6. And label it as the inverse of the original function you started with. So this will be f inverse of x is equal to x minus 2 over 6. Super easy? Okay. If the domain of this guy was all real numbers, then what is the range of this guy? All real numbers. If the range was all real numbers, then the domain for this one is all real numbers. They're actually swapped. You can't see that they're swapped, right? But they work. That's why I did them separate. You'll see that they swap on this one over here. Okay? Are we good? We're almost done, I promise. No, this is a tough lesson. And we haven't even gotten to calculus yet. This is all review from pre-calc and algebra 2. Okay? Find the inverse of this guy. So before we do that, let's draw a sketch to see if it has one. Any of you remember how to draw the square root function? Like that. Oh, very good. So what does like that mean?
Like that.
Oh, like that. Okay, so like that. Okay? So for the video, we draw it like that. Okay, so it's like that. Got it? So it's like a diver, right? He's on the diving board and he jumps off, right? The path that he's following is kind of like the square root graph. Okay. But if you notice this one was transformed, right? It moved. So how did it move? Does anybody remember?
Up 3 to the right 5.
Up 3 and to the right 5, but it says minus 5.
It's a trick.
It's a trick?
Yeah.
Oh, okay. Whenever it's inside something, right, it's always in the opposite direction, left or right. So here it's actually going to move 5 to the right. So 1, 2, 3, 4, 5. And 3 up. 1, 2, 3. Whoops. It's kind of like this. Cool? So does it pass the horizontal line test and the vertical line test? Yes. So does it have an inverse? Yes. So let's find it. But before we do that, let's write down the domain and the range. So what is its domain and range? Because that's going to be important. 5 to infinity. That's for what? The domain? So 5 to infinity. And I guess we're writing it in interval notation. Is 5 included? So I put brackets? Yes. Okay. How about the range? What's the range going to be? 3 to infinity, right? And 3 is also included. So domain, remember the x's that you can go to and touch your graph. The range are the y values you can go to and touch your graph. Good? Alright, so let's find the inverse. Ready? We're going to get x is equal to the square root of y minus 5 plus 3. Let's do it, Anias. Quick. What do I do? Minus 3 minus 3. We already did. Come on, man. Keep up. Senior week's over. X minus 3 equals the square root of y minus 5. Hello? S squared, very good. So when you square one side, square the other. X minus 3 squared equals y minus 5. Finish him. As they say in Mortal Kombat. Plus 5. So y is equal to x minus 3 squared plus 5. Bless you. And this one would be labeled as the inverse of what? Of g. Okay, now I gotta be careful here because this is a what? What does the graph of this one look like? A parabola, right? But I don't have a parabola here. So how could the reflection of that one give me a parabola? I need to cut the domain, right? I need to limit it to where I don't have the whole parabola. I only have what? Half of the parabola that I'm going to reflect, right? So how do I know which half that's going to be? If the domain here is 5 to infinity, that means the range over here is what? 5 to infinity. If the range on this one is 3 to infinity, that means the domain on this one is 3 to infinity. Because what happened to my x values and my y values? I don't have the whole